We have a lot of data, and we're continuing to do more and more data. And my slides disappeared. Oh, there they are. But first and foremost, the really cool part about working at Nuna is our founders and executives they believe in security from the get-go. So we have 100% backing. There hasn't been one time that we've gone and said, "Hey, I need to hire another incident responder. I need this product." They go, "No, justify it." It's kind of been cool to actually be in a spot that they just sign off and say, "Yeah, go get it. We need this." But enough about that. What's the problem here? Traditional corporate networks do not apply to these new companies, and especially at Nuna. We like to consider ourselves somewhat a hipster company. We're this very fast-growing, dynamic, a big mix of everything, big mix of the type of technologies that we use, the different stacks. Our stacks are constantly changing. We continually deploy and tear down machines. There seem to be a lot of lack of players in the game, or people who are truly going after this type of community or this type of company. You're still seeing a lot of these cool, new, innovative designs or network appliances for network security, and it's like, really, oh, that would be awesome. I want to get that, but fuck, I can't get it. It's only if I can have an appliance in my rack or a network tab, and yeah, I'm in the cloud, so I can't do that too much. I'm not a big player, so I don't have a lot of money. I can't convince Amazon to go give me this separate cloud rack with all this stuff that would be really, really awesome if I could. So we're having to do things a lot differently, come up with our own unique solutions. There are some awesome solutions out there. I will list some later on in this presentation. A lot of them we're using effectively, but a lot of stuff we're having to attack very differently. And when we talk with these companies that are doing these traditional appliances, we ask them, well, can I replay traffic to you, or do you really need a tap? And the answers are like, no, we need a tap, we need this. And so we're trying to be dynamic in the solutions that we create and that we're actually deploying here at Nuna, because we, in fact, are cloud-based. We do have a distributed workforce, and we're going to step into what I mean by distributed, because not everyone might have the same idea of distributed as what we think of at Nuna and the security team. So traditional corporate network, it's very common. I took it from online. It's, we've got a bunch of users, some servers. You got our mail servers, the DMZ, some firewalls, an IDS. If we were to tap this network and think, where could we actually monitor some stuff, the main place would be the IDS system. That's the central point. Things come in and go out. That makes sense. But does it always look like that for us in the cloud, or can we even get that type of information? So when I say distributed corporate network, this is really what I mean. I've got a region of AWS over here with a VPC. I've got a region over here, some different VPNs in. This gray cloud in the middle is the mysterious internet, where good and bad things happen, I guess. But then we have some places like the bottom right. This is what I call HQ. We're our own set, but really I should have drawn the bottom right, like this guy on the left over here. Everyone that we consider at the office is a unique node, a unique VPC in sorts. Even though that we go to the office and there's over 100 people there at any given time, we don't consider it a single network. We consider every laptop separately, as if they were on their own network, as if they were working at home, working from Starbucks. So we attack things differently. We don't try to do network monitoring at a corporate level there with like a bro instance, truly because we have some quirks and like, why should we do this? Will it really benefit us? Does the time that we are going to take and the money that we spend, is it going to be really beneficial, or can we attack this a different way? And so that's kind of what we're doing here at Nuna, and which is really, really exciting because we get to do all this fun research and try things. If it doesn't work, we go do something different. So we're in a unique position. But first we have to think, how do we internet again in this distributed network? So that's what we're going to talk about. So how can we monitor now? In AWS, who's familiar with AWS? Does anyone use it, deploy it? Anyone have awesome monitoring deployed? Can see everything that happens, know whenever a key's made, whenever someone creates a bucket or accesses that bucket. If someone creates a policy that is beyond what it should be based on corporate standards, it can be very difficult and it can be hard to do things. Who can see all the network traffic in their AWS infrastructure? Yeah, no one raised their hands for those of you who can't see in the back. It's really, really hard, and this is what we're trying to address, and some things that we're doing at Nuna in order to tackle these things. Because at AWS we have things like CloudTrail. And if for those of you who aren't familiar, CloudTrail is like API-based monitoring. So whenever someone creates an API key, uses it, creates a bucket because of that key, things like that. So I can only tell API-based actions. So what access keys are being used, when, how, where. They have CloudWatch, which is really cool, but this is more like infrastructure monitoring. Like, oh fuck, my server went down. Quick, deploy. Really cool if you're doing things like VPNs. You can autoscale group of 1 if you need, and if it ever dies, it just redeploys right back up. It's like, sweet. Awesome. But yeah, not too much information. VPC flow logs, when I first heard about this, I was like, hell yeah, finally network security monitoring in the cloud. Wrong. You can get to and from, or I guess from and to, and accept reject. MTUs, it's kind of like, I sent a packet from this machine to this machine, and it was accepted or denied, or I'm getting this traffic here, but you can't actually see what's in that traffic. So that's a problem, because what are you going to get from that information? Okay, this guy from Israel is like hitting our network, but he's being denied, so that's all I know, but we can't see what kind of data he's trying to send, what he's actually trying to request. And it goes, for us here, we're truly tackling this at a individual user endpoint being the laptop, but also we're applying these concepts to our endpoint servers as well. But at HQ, how do you do monitoring? You can do network logs, put in a bro IDS, SSL termination if you so please. But how do you do that if your workforce is truly distributed? Like at any given time at Nuna, we have about 70% of our workforce in the office. We have a bunch of people working on the East Coast for us. But at any given time during the day, I'll have 2 of my guys from the team decide that they're going to go do a sync at Starbucks. Or you'll go to Starbucks to get a coffee and you end up, like, half the engineering team is over there. Because they just got distracted by what's going on. It's this new startup, open space, people get distracted, they just need to get away. So how do I protect people at Starbucks? Fuck, I don't know. What about at home office? Since we have a bunch of people working on the East Coast, we don't have an East Coast office, so they're just working out of their houses. So how do we protect that? We don't control their network. We can't see into their network. So it's really difficult unless you have some sort of always-on VPN. But in our case, we're in the cloud, so if we're always on VPN, all we get are, okay, you connected to our VPN, and now you're trying to hit these servers. We still aren't getting the traffic that you're wanting to actually see, because we don't have those network taps. And I'll talk about the issues here. And as I mentioned, 70% of our people in the office at any given time. This is probably a big number, especially on like a Friday or a Monday morning. And then at any given time during any big client engagements, we have a handful of people out of the office. And this 70%, it's rotating. It's not the same 70. So it's not like we can take the 30% who are never there and apply different things to them, and then the other 70% are always secure in some ways. We have people who go travel to India or to China and visit their families. And we still allow them to work from there because they need to get the job done, and we're a startup and we have to move fast. So we're no network taps in the cloud unless you're big and you have money, and then AWS is willing to work with you. They say, hey, let's talk. Maybe we can get you this, we can get you that. AWS is good. They can now transfer a lot of big data into AWS with like these hard drives that they ship you. You load the stuff, you ship it back. They'll actually rack mount some hardware appliances for you and hook it up and tie it into your VPCs. The problem with that is your VPC better be well defined. You better not add any subnets because you're going to have to just make all these requests to Amazon. Hey, can you change this? Can you change this? Can you hook this up? The cool thing with AWS and what we do at Nuna is it's completely distributed, completely dynamic. At any given time, we might redeploy a system daily once or twice, or weekly several times. So those are things that we're doing in order to protect ourselves and protect the client data. Is we're constantly moving, we're constantly redistributing things, and we're actually adopting processes that you might not normally think of when you're in the security. I'll talk about that here in a little bit. And so VPN is not required for all of our work. So you'll find oftentimes, even when they're at Starbucks, they're just working on code locally, or they're not actually distributing or deploying code, so they don't have to connect to our VPN. Or there's certain systems that, in our third-party cloud providers that you don't have to go to the VPN to get to them. So you can't rely on something like that in order to protect all your data. And then once again, we're back at even though there's in a secure connection through the VPN, we can't see what they're doing. So that's a big problem from a security standpoint. And Ethan up here up front works for me. He would say, I need logs, I need headers, I need all that good stuff. Show me the data, give me the data. And then once of all, the biggest problem in any company, I think, is you can't trust the users. The users are going to click things, they're going to do things, they're not going to follow processes. Set them and think they're hardened and in place, and you're going to be wrong. I can tell you time over time, again, I've been proven wrong at Nuna, at my past positions. People go and skirt processes all the time, so you have to attack this problem with the mindset that people are not going to do what you really think, and start guessing what they're going to do so you can protect yourself. So how do we solve this? There's a couple approaches, and I'll talk about one more particularly in this talk, and how we're trying to get some interesting things for network security monitoring. But we truly treat every endpoint as distributed. My laptop right now, I'm on my phone, or I guess hotspot, and I'm considered a separate node of our network. It would be the same if I was on my hotspot at HQ or just at HQ's Wi-Fi. We're truly, everyone's separate. There's no way that we can get into each other's computers like you would at a corporate network. We do have some cool configuration management type stuff where we can push packages, pull packages, run some really cool dynamic queries. We'll talk about that a little bit here in a bit. But we're trying to do things differently, and what we're finding is we can't just go buy a solution. So some of the things we can buy, some of the things we're having to create, and some of the things we see we just don't like and we want to do it. Or it's a little too heavyweight, so we're going to do it a little less lightweight, or we want it more customizable. But today I'm going to talk about kind of a simple proxy type solution that you could put together and distribute across your employees and get some more insight into the network, because we don't have things like a central networking monitoring with Bro and that kind of stuff. So even at headquarters, we're different. Don't assume the standard workflow. As I mentioned, we're not going to always connect to the VPN. I can tell you I look at our concurrent users on our VPN at any given time, and compared to the number of people we have, like say Nuna, we have 110 employees. At any given time, we might have 30 concurrent VPN connections to our main tools VPC. That's not a lot, considering our engineering workforce is like 70 of the 110. You would think you'd get more, but that's because people don't connect to it all the time. They like the freedom of Wi-Fi and being able to roam, and they like being able to just connect and not have to be worried about being forced through a VPN and the internet speeds going down. So be creative. Don't be afraid to create something. Create something, put it out there, open source it. Everything we develop at Nuna is going to be open source at one time or another. Spoke last month at AppSec California on our new identity management infrastructure. That's open source. We're deploying it right now, and once we get it out and tuned correctly, it'll be there for anyone who wants to look at it. It's kind of like crypto. Put it out there, people break it, you fix it. That's the one thing about, we saw the tales of the bug hunter, right? Researchers can be very friendly. Don't piss them off, or they could be really, really mean. But yeah, learn from others. People talk about things so you can learn, and do it. Just because OpenDNS or someone like that published something doesn't mean you can't use it. Use it, and use it proudly. Talk about how you applied it or how you changed things to fit your network or your corporation. But learn from others, and especially as a hipster company, you got to move fast. You got to do things. Don't invest the 6 months to develop a solution when it's out there just because you want to be proudful and be that company that developed it. Just do it. Nike did not pay me for that, by the way. So I mentioned some things that you wouldn't traditionally contribute to security, except there is a talk, I think, at the end of today about rugged DevOps and security. But DevOps, CI/CD, CD, continuous integration, continuous delivery, continuous deployment. And I like to say CD, 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 CD. And that's because we deploy things all the time. Hack our box and we redeploy. Like, it's really, really cool. You can do these cool things, but you have to learn from others because someone else has already done it. They're already talking about it. Go learn, apply it, and figure out if you can apply it better, and then provide back to the community. That's like one thing here at Nuna. Everything we're doing, we're trying to give back because we didn't think of all this cool stuff ourselves. We use a lot of really interesting systems that people like Netflix, people like OpenDNS, and other really awesome companies that have been out there in the space for a long time are doing. It makes my job a lot easier. So we're truly talking about doing agent-based approaches. Due to the fact that your corporate network isn't like your company network now isn't a traditional corporate network. You have to think of things differently. So brace yourself, Houston's, we have a problem, right? Not many agent-based solutions exist, or not many that exist that can actually do what you want. There are some, but you'll see like the big companies at RSA, yeah, the evil RSA word, sorry guys, they're going to show you really awesome things that you have to rack mount, or it's good for your corporate network on-prem. So depending on if you're totally cloud-based or if you're on-prem, it might work for you, it might not. But even if you're on-prem, agents work really, really well, especially if they're lightweight and the users can't even tell that they're there. So OS Query is one. Facebook, awesome. Who uses OS Query? Anybody? It's really, really cool. We use it. We even have dynamic ad hoc querying that we're doing. So if we suspect that you're compromised, we push these random OS Query SQL commands out, and then get that information back. But we keep it lightweight, as lightweight as possible to, one, not bog down our logging system, and two, not create a unworkable environment for you. Cylance, their AV solution is pretty awesome. Very lightweight, agent-based mathematical model. Doesn't require you need to be on the internet and connect to a back end to keep your signatures up to date. Really interesting. Tenable, they have a agent-based vulnerability scanner now. You don't have to actually have your Nessus scanner reach out and scan boxes. You can have an agent actually scan the system and return the results to you. Yep. And OpenDNS Umbrella, really awesome. DNSSEC all the time. And then this latest glibc, OpenDNS was protecting you before you were able to patch yourself. Really, really sweet. But this is an exhaustive list. I couldn't tell you. I didn't go do the research of what agent-based solutions are out there. They're coming out more and more, but people are still thinking in the traditional sense. So solving network monitoring. How are we doing this at Nuna? And what could you do at your company? So let's define a proxy. We can't monitor the network in the cloud because we need a tap, and in order to get that, we need a lot of money, or we don't have Bro installed and we don't plan to at the corporate office. So how do we do this? We first create a local proxy installed on the user's machine. Very similar. Anyone ever use Burp? Right? Lots of hands there. Burp's awesome. You can proxy stuff. Has anyone ever used Python implementations of proxies? Written their own scripts so that you don't have to go do things manually in Burp? Applying that same principle, let's create a lightweight proxy for the internet here at our Nuna corporate or any of your companies that you want to apply that to. So it's got to be very lightweight. We might want to support SSL termination, probably so, especially if you force HTTPS traffic in all of your requests, and make it very configurable. And we'll see why here shortly. But forward logs, but make sure that we don't forward all the logs. As far as who's seen that meme forward all the logs? Yeah, fuck yeah. Anyway. Define classes. So with anything that we're writing, we want to have a well-defined structure of data that's actually being sent back and forth. So we're tackling truly the web proxy right now. HTTP, HTTPS, anything over standard web. So we have requests and responses. So we define this simple request class. We've got cookies, headers, the actual content, what host are we going to, the full path, right? Because if any HTTPS, all we're seeing is the domain. We don't know the full path unless we're actually monitoring that network traffic. What HTTP version are they actually using? Is it as old 1? Is it brand new 2.0? How are they actually doing that? And what method are they actually doing? Are they getting? Are they putting? Deleting? What kind of stuff? Can we see malicious stuff? We should never be deleting, but we're seeing all these deletes fly across our network now. That's not Nuna standard, so who's on our network? Responses, what actually comes back? The cookies that come back are headers, content, all the good stuff. This is the good, juicy stuff, especially for all you honeypotters out there that like to see the malware that comes back. Here it is. Get the content. But then, most importantly, let's define this PCAP kind of standard that we're going to use across the enterprise, which contains these requests and responses, but also some other stuff, timestamps, source IPs, destination IPs, ports, something to give you more that if you needed to go back through and actually look through the logs on a system, you have some more juice to go with. But things to consider when you're actually designing something like this. Don't invade privacy. SSL termination's pretty scary. I've noticed when we push new things out to people, or when we use Duo at Nuna, and we started applying people or our end users BYOD devices that they have to have a certain version of the operating system. It freaked our users out. We got so many requests like, what the fuck can you see on our phone? It was pretty crazy. And we had to do this like big talk or a big like Slack conversation on, all right, this is what we can see. Should I point you at the SDKs so you can see what every app on your phone can see? Oh, and for the 5 of you that are rooted, yeah, who knows what those other apps are looking at. But if you're scared of the Duo app, you've got bigger problems. So yeah, privacy is something that we're having to juggle a lot. Like, what sites do we actually intercept, or which ones do we pass through? So here's some examples like Bank of America, Gmail. Maybe we don't want to read our users' personal emails. They'd probably feel very invaded. How many users? Do you have a question? Yeah, very, very carefully. So yeah, you have to protect your private keys. And luckily, if you have like a configuration management or system like Chef or something like that, since we're the hipster company, we're not using SCCM. We're not a Windows-based. We can push and change these keys as often or as infrequent as we want. But yeah, it's very hard to protect those keys, especially since they're private. They live on the box. They have to be on the box in order to sign the requests and actually intercept. But yeah, it's one of those certificate management issues that everyone hates to tackle. It's very hard. If you do it wrong, you're fucked. You could even go into something like in the bug hunters talk earlier today about how the guy was able to get SSL keys and all that from an S3 bucket. Like, do it wrong and leave a hole open, it becomes really, really tough. But yeah, it's definitely a problem keeping private keys local. So you have to put them in places or protect them or constantly rotate in order to truly protect that. No, unique keys for every machine. Yeah, no superfish. And then one of the cool things with our environment is we have different roles and different things. So we can choose whether we want to actually push this out to someone or what kind of keys we want to share, and how frequent we can do it. But since it's all, the DevOps fashion, we can automate things and continuously push things out. You do have the problem that if someone doesn't connect back to the network, or if there is a network problem, that they don't get the new key that's pushed out. So there are a lot of things that you have to consider on if you're going to do something like this. This is something that we've just been toying with. We're not actually deploying something like this yet, but it's been fun to develop and figure out all the problems, especially because if you are doing SSL termination and you forget something like SSL verify upstream cert, then you really have an issue, because then you're not going to catch all the self-signed websites, the websites that are trying to look like other people. That's when you get into definite issues, because you're proxying, you're signing things as a root authority, and all of a sudden you've come across this phishing site that they're making it look like you, and you allow it, or that your user isn't prompted with a bad certificate, or in this case, any certificate that's verified upstream we drop, so you can't even access those sites. And if it's something you really have to go through, you have to submit a request. So it's those processes that you have to think of, certain things that you have to do, and a lot of testing and research to figure out, is this something that's even viable? Should we do this? How dangerous is this for us? Does it make us more secure or less secure? Do I want to publish our key anywhere? I think I've seen 2-3 different cases of people publishing keys and doing some superfish. Like, was it McAfee that their antivirus Chrome extension had all sorts of man-in-the-middle capabilities? I forget. But be dynamic is the most important thing here for us, at least. And I'm sure any of you guys that are using central logging, how much data do you actually want to capture and that you actually have to go through? And does it make sense that we capture everything, or do we only capture some things if we think someone is actually exploited or infected? So what do we do? Do we log all requests? Do we always log the headers? Do we only log request headers and only response headers sometimes? For content, do I care what's being sent? If I log request headers, I risk the possibility of logging sensitive passwords. But maybe I want to do that and detect if people are actually sending passwords to some phishing domain. And if I can detect that our passwords are being sent out somewhere else, then we can auto lock and reset user systems. It's kind of like the Google password extension. They try to detect when your Google password is being used elsewhere. So it's kind of cool thing to consider. It's a fun, interesting problem to think about. And if you talk to any incident responder, they'll be like, I want all the data. Give it to me. But it doesn't make sense, especially if you use something like Splunk. It's really fucking expensive. So we have to play data games, and that's why we go with things like being able to push dynamic custom configs to people's systems and say, I want to see everything that Ethan's browsing today, all the content and the requests, because he bounced his traffic through China yesterday or something like that. Be dynamic, don't log everything, especially because if your users end up seeing that you're logging everything or get the word, and being in a hipster company, we're fully transparent in what we're doing on the security side, and people talk, and we have like 100 security experts in our company. The worst thing we did was make a public security channel in our Slack. Because people will report a phishing domain or something, and then we have about 10 analyses of it before our IR employees can actually get their analysis posted and something in place. We have all these people that think they know what they're doing, or they're aspiring to be a security professional, and they end up making us even more at risk. We saw some site once that was like a proxy to GitHub. It looked just like GitHub, and people started, it logged me in, and I was able to get to my GitHub. I'm like, oh my god, fuck. All right. It's the best and worst thing, because we can educate people through security, but people click links all the time. And then you think, from the security standpoint, I'm going to just kill all the links in Slack, and it's just going to be text. And then you're going to get all these requests like, you fucking suck. I can't click a URL from Slack. I have to copy paste. My life is horrible. We hear that stuff all the time. We'll create phishing plugins or things like that to help try to detect links that are linked to other places, or we do this math calculations to try to determine how fishy is a link, and we start doing things like that, and people are like, I can't go to this page without it popping up a warning. I said, what page are you going to, and should you be? People browse all the time, and they think, but I browsed in my non-Nuna Chrome profile, so I'm safe, right? The company's safe. Was it on your Nuna laptop? Yes. Are we safe? So yeah, lots of fun things to consider, especially when you're coming up with new, unique solutions. So this has been one that we've been toying with. It's a hard problem. It's something that it might be good in the end. We might just toss it out and decide this is way too dangerous, and we don't want to be on the cover of every national news site because we're the now healthcare superfish. So future, what can we do? Being a healthcare company, we have access to healthcare data, and we have requirements like no PHI, personal healthcare information, should ever be on your laptop. I'll go back to the issue that people don't follow process very well, or people think they might be following the process, but they forgot to tunnel through that one box to get to the other environment before, or they had something cached and they thought, oh yeah, this works, cool. And then you end up with a boatload of PHI on a local system, and then you're performing cleanup. Or they have PHI on their system, and you don't know about it. And then when that laptop goes stolen, you don't report any health records being lost because you weren't aware, and the user didn't really know. So could we do some sort of agent-based local file system monitoring for sensitive data like social security numbers? And if we tag something like social security numbers, should we look for other things? And one of the most important things when tackling a solution like this is truly understanding what does it mean to be PHI. And since I work in healthcare, it's a hard problem, and this is what I'll talk about a lot, but it applies to every industry that you work in. what does it mean to be proprietary information, or what does it mean to be personally identifiable information? Like, what does this field actually mean? Because in this case, it's just an ID, but in other cases, it's a social security number. So, oh, I didn't know that, but I downloaded a whole list of that to my computer. So we're looking at things like this, like how can we detect things locally on a system without like sending them through a proxy or having an agent that actually searches all of our documents in the cloud. You had a question?
Yeah, well, the 18 PHI identifiers, for which the 18th is other, they're very hard to detect, particularly because dates are PHI.
Yep.
Zip codes larger than, smaller than a certain size are PHI. So are you really talking about detecting all of that information? I mean, it's really going to solve the problem.
It is. So in the end, I mean, the overall ideal goal would be that we could do that, but we're starting simple, and we're going to move to more complex systems. And that's the one nice thing about being in security at a company with a bunch of data scientists, is I can pull in and say, hey, let's tackle this problem, or what are your thoughts? How could we try to detect this type of information and be successful? And they might tell me, fuck off, you can't do it. We can't even tell you what PHI is when I look at data half the time, because it's very complex, and this last name with these 3 digits of a zip code, but combined with this address, all of a sudden it's PHI, and you're just like, oh, I did not know that. So it's one of the biggest problems, but to me it's one of the most fun things is to research this kind of stuff and figure out unique solutions. Because if you ever could figure out how to do this, be it through mathematical process, something like Cylance is doing with antivirus, if you could figure out how to mathematically do this, it's going to be, and I'll jump to a couple bullet points, but there it is, the next big thing. Yeah.
Did you say you are running your stuff on personally owned devices as well as company-owned devices?
Oh, no. So the only personal owned devices are users' mobile devices, which are used for like two-factor and Slack communication, stuff like that. But actual work data can't leave our protected cloud infrastructures. And we actually do have things in place to prevent stuff like that happening. But I talked about social engineering protections. We do a lot. We hired this PhD software guy that's doing a lot of mathematical analysis and trying to figure out the problem to phishing. Because I come from a pen test background, big red teamer. If I couldn't get into your network, I could find a user that would let me in. They would give me their password, and then maybe reset the password, and they would change it, and then I'd roll that password by one number, and I'm back in. Or they think, oh, we use two-factor authentication, you can't get in. Yeah, no. Like, who thinks with two-factor authentication you're protected? 100%. A little bit, right? You're protected from the fact that they might not be able to get in twice, but they're still getting in that first time if you're being a dumb user. And we have lots of dumb users. I'm not saying all of our users are dumb. A lot of them are. Including ourselves. I remember designing a phishing exercise at our company and sending it out, and like it got queued in our email server, and I was off, it was a squirrel moment, and I'm off on another topic, and all of a sudden I got this email, I'm like, oh my god, and then I'm like, fuck, that's my phishing email, don't click that shit. Almost did it. But yeah, I truly think agent-based solutions, at least for Nuna, and your companies, I'm sorry if it doesn't apply, but agent-based solutions are what we're doing. It's what works for us, especially as we're this new up-and-coming company. Yes, we have money, but we don't have buku bucks like a Facebook or something like that. We can't convince people. We're never going to have on-prem because it doesn't make sense. We're too focused on our product and evolving than trying to maintain and run our own things ourselves. And we're adopting these new things like DevOps in all of our practice. So my VPN server is only up when I need it. It might be redeployed every week. It might be redeployed every night. So if you do actually own one of our systems, you better get the data fast kind of deal. We get to do things like that because we're this hipster cool company, but we're doing mainly because we're using cloud solutions and we're applying these concepts. But these traditional things don't work for us, and we're investigating all these cool agent-based solutions, which are awesome, scary, and fun, I guess. The research is great, but it brings up questions like we had earlier. Are you using the same cert on every box? How are you solving this problem? It's things like that and a lot of testing that brings these open to us and not leave our company with this huge goal or this huge gap. But yeah, that's all I really had today. Does anyone have questions about anything?
Sorry, one other question.
Yeah.
So, your excuse for moving everything to the edge is to endpoints, is that people don't like going through the VPN. Another more traditional approach would be create a powerful VPN, authenticate everybody through the VPN, make that a single point of control, monitor everything at the VPN, and use that as the bastion to connect to your cloud.
Correct.
Why didn't you take that approach?
Yeah. So we've actually thought, and it's still in our pipeline, on whether we actually want to have this auto-on VPN for a safe browsing, at least corporate network monitoring solution. And we could choose to do some on-prem, really powerful VPN and then have some Bro IDS. It's something we haven't done yet, mainly because it's something else we have to maintain. But also, it can affect user experience. And as fast as we throw systems up and create these new client environments, we constantly be reconfiguring that VPN as well. Because we'd be forcing people to VPN from their home to our corporate office, and then VPNing to another cloud somewhere else where the personal health data lived, or something like that. It's a lot of in the air, cards moving around that we're not really sure how it's going to play out as part of being the new hipster company and being very dynamic. But and also we're total cloud based on at least all of our production infrastructure. So we'd get monitoring into browsing if we did something like that to our home-based VPN, but then we have a bunch of different unique environments that we have to connect to based on our roles. That once again, we're in the AWS problem where we can't tap network traffic. So it becomes, it's like a chicken and an egg type deal. We solve it here, but then once we actually go do real work, then we can't get that information. But maybe we put a process like you only connect to this VPN when you're accessing the PHI or this kind of data, and every time else you should be just connected to the network. But then it's one of those things that we can't kick people off the VPN if they're logged on too long. It just cuts the workflow, or they might be deploying a system. And it's the thing that, I forgot I was connected to that VPN, so you couldn't monitor everything, and that's when I got pwned, or that's when I clicked that link. Or called. We've had people actually browse to some site, and it's one of those, your computer's infected, call us to help you kind of deal. But yeah, that's why we haven't gone that auto-on VPN forced route all the time. In the back.
What are your thoughts on hardware tokens like YubiKeys, that sort of thing for authentication?
Yeah, I love hardware tokens. I use them, we have them. So at Nuna, we've deployed hardware tokens if your device doesn't meet Duo, our Duo policies. So we have these strict Duo policies, or semi-strict Duo policies, I should say. I wish they were stricter, but because of our users and because everyone's so cool and rad, and they understand that not encrypting their hard drive is a good thing, or whatever they think. But yeah, so we're deploying YubiKeys on certain things. Some devices you actually have to have a YubiKey hardware token to actually authenticate. You can't use any other 2FA. But also, we do things like if your device doesn't meet our Duo mobile policy, then you can't use Duo push technology or passcodes. You have to use a YubiKey, which people think, oh, great, I don't have to worry about it. But then you think, oh, shit, I don't have Slack on my phone anymore, or I don't have, they forget the fact that they can't put a YubiKey in their phone to authenticate to stuff on their network. So we've basically solved the BYOD problem for us that way, in the fact that they can't get email, they can't get Slack, they can't get other things without actually having a decently secure phone, or what we think is decently secure. In the back? Yeah.
Do you have any kind of response capabilities built in? So, like, if you detect somebody's downloaded a piece of malware or somebody's attempting to export that private key, do you have any response capabilities to go through the shortcodes that export it? Possibly using like integration on machines?
Yep. So we have ideas on how we would do that. Once again, we haven't deployed this across our corporation, so it's not something that we have to have in place yet. But there have been some good talks on how you might do things like that. We do run things like OS query all the time, so we know changes. OS X collector is one that gives us a lot of data on our Mac systems, especially at times where we think, why are you hitting this botnet traffic? Or we've seen botnet traffic. Is it because you're browsing to a site that has a bunch of malicious ads that are loaded, or you truly have something on your machine? But we're toying with how to connect systems like GUR, OS Query, OSX Collector, and our configuration management system to actually do these. I think we might have had a key go out. Let's collect some information automatically and have it there ready for investigators so that they don't have to then go do all that things. We do have rapid alerting. We use Splunk heavily. So all of our data is going into a central location. We have really awesome alerts that generate automatically generate tickets. And if you're interested in more stuff that we're doing, Ethan talks tomorrow on kind of that kind of thing, and how we're actually doing some stuff to protect our users and actually try to rate our users at who's the riskiest person in our corporation at being phished, and maybe we monitor them more than others. But yeah, we're setting up these automated pipelines that if we detect things, or if you meet a certain threshold, that we saw these kind of requests and traffic from your computer, that we automatically run these collection agents and then send it back. Our IR teams built visualizers around that data, so we don't have to go parse JSON logs manually. We can just instantly load it up in one of our viewers and see it. Question here?
Is someone prepared to deal with another standard? You talked a lot about PHI, but how about PCI or IPA or anything like that? Is someone ready for it?
Yeah, so the question was, how are we looking at other standards like PCI, for example, and are we ready for that? Luckily, as a company, we don't have to worry about being PCI compliant. We're truly, HIPAA is our biggest concern, and the different various compliance factors that go along with being a healthcare company. So these things that we're doing are truly focused around PHI. But a lot of the things we're doing would solve PCI issues as well. I could see those fitting. You'd basically be changing rule sets that we write in order to meet PCI. And most likely when we actually release something like this that we are using, we'd have rule sets for other things like PCI as well. Because it's data we would want it to see as well, especially if we have corporate credit cards. We don't want that information coming around our different systems. And we're mainly looking for, I say it again, stupid users and what kind of data they're using it. And I just say stupid users. They're not stupid. They're probably some of the brightest people in the world, but they're just not very security savvy, I should say. They don't know that what they're doing is causing problems for us as a company. Any other questions? In the back?
Basically ignoring Gmail for privacy reasons.
Yep.
If you're talking about stupid users or not security savvy users, wouldn't email be one of the primary ways they might transfer information?
Yeah, you're right. Gmail might be ways, and I've actually seen like proof of concept code that is using Gmail as a CNC, command control. So yeah, it might not be the best thing that we do to say, let's not monitor Gmail. So this was just an example. This isn't actually what we're doing. So I would just say, if you want to look at Gmail, you can. Sometimes, as a company, like when I worked at Lockheed Martin, I couldn't get to Gmail. It was just blocked. If I wanted to do personal email, I had to do it on my own system. So how you want to tackle that at your company, this is just an example of how you could do it. Obviously, if there's more banks than Bank of America, so our ignored list would be a lot longer than this. But you can also tackle this other ways as well. But yeah, Gmail, I'd definitely tell the users, if you want to do personal browsing at work, you're going to be watched. So if you want to send personal email, do it on your own machine. Because there's proof of concepts out there, and I don't know how many advanced threats are actually using things like Gmail. But yeah, it's something that we have to look at because they use Reddit a lot too, or Twitter, and yeah, it's a dangerous world. Any other questions?
Agents should work
So right now we're not focused with agents on the phone because none of our actual company data is allowed on phones. The only thing they can actually have on phones are like Slack communications or email. And at any point we can expire your email session and the email gets automatically wiped. And then Slack communication, our traffic's not logged, stored for more than a certain number of days. So it's something that, based on our policies, we're not allowed to send files with our PHI data over Slack or anything with that. So it's something our team monitors a lot to make sure that nothing's doing that. We have a policy that there's only a certain number of private channels that are allowed to actually exist, but we're a truly transparent company. So I find a lot of bad things in our engineering and our products basically by joining the engineering channels in Slack. And I find all these things like, oh, I can go here and get this, that's bad. And then I give them more work because they have to go fix it. But yeah, transparency is a good thing. But yeah, we don't tackle the mobile problem, mainly because we don't allow much on our mobile devices. But we do have certain number, if we were to tackle that, we'd then probably offer corporate devices that we can truly manage. But with anything, like I remember when I worked at Lockheed, I could use my personal device if I agreed that they had access to the entire system, and at any time they could wipe anything or log anything. And a lot of users probably won't do that, especially this day and age. They freaked out when we told them that what versions of their iOS and Android they were running. So I think they would really freak out if we were having them install apps that were doing monitoring on their devices also. Any other questions? Yep, in the back. Yes, scaling is definitely a problem, especially in how lax some of our processes or like guideline policies are. One of the things that we're looking at is a whitelist approach to browsing, as an example. It becomes a problem really fast if not done correctly, and that's something that like Ethan here has been working, especially because one of the biggest risks is interrupting workflow, or if you're in a big sales presentation and you're trying to get to a website to make your demo and it's not on the whitelist and then you're blocked. That's a really, really bad thing. This is kind of the same where the ignored list could be a problem, continue to grow. That's why something like this is, we don't put it, as fast as we move it as a company, we put a lot of thought into how this would adversely adversely affect our population before doing it. And since we do distributed data and things like that, we're very familiar with scale, at least our DevOps. That's one reason security works so closely with DevOps, is so we can do things better, faster, and at scale. So that, yeah, this would be something that it would have to reach back or be pushed out continuously with our configuration management or our chef systems in order to stay up to date, and would have to be constantly reviewed to think, are there any known threats using these sites? Like, if Bank of America had this cool chat feature all of a sudden one day, right, we'd have to rethink on whether we would monitor Bank of America or not. But yeah, it's something that any of these solutions that have any sort of ignored lists, it can be really hard to maintain. That's part of the reason we're still trying things out and trying to get a feel for, and I guess feel and guidance from our privacy group on what we should be doing.
Yeah, I mean, whitelists are hard to maintain, and like 3 standard deviation points go from 0 to 0.
Yep. Yeah, no, it's one of these problems that I think that constantly trouble me and are fun to research and figure out. Because how can we create a truly dynamic whitelist if we're looking at the whitelist approach on how can we effectively whitelist things, especially if the whitelist is contained at an agent level, and how does it continuously update and, I guess, grow autonomously without leaving us, exposed. Because I don't want to hire someone to go handle whitelist requests all day long. they're much more valuable doing other things like monitoring. Any other questions? Cool. Well, thank you guys for coming out. If you have any questions, I'll be around.
Okay, so thanks to Will. Again, I want to thank our sponsors, most especially Fitbit. We've got another track coming up in about 6 minutes, so stick around.
So you talked about Cylance, and you brought up Tenable and some of the other ones. They would be competitors to us.
Oh, really?
And so,
nice. Well, we should talk because
the issues they're dealing with is you buy a sandboxing technology or a forensics or analytics tool like any one of them.
Yep.
You're still dealing with ghost alerts and false positives.
Mm-hmm.
That is a fact,
yep.
and that's our sweet spot.
Yeah,
and that's where we kick their ass. And we mitigate in less than 7 seconds.
Oh wow!
There's no vendor on the planet that does that today.
Man, we did a proof of concept with Carbon Black, and we fucking destroyed it.
We found
so many ways around.
We were just in a think tank meeting with those guys, and their VP of sales is, "You guys are eating our lunch. This is the VP of sales for Bit9 for the West Coast. We definitely need to talk."
No, definitely, because we did Carbon Black. I was really excited because of the process, like recording and all of that. But yeah, we found so many ways around their blacklists, and easy stuff like encoding something 4 times got past their malware detection.
I'll tell you something.
Like interpreter shells getting past Carbon Black out of the box is bad.
Oh, you are? I don't know if you replaced it. That's fine.
More than others. I get made fun of volunteers. I got it. That's very bad.